next question would be, is there any NH or OH? If there is NH or OH for alcohols or for amines and amides, we have a broad peak around the 3300. For alcohol is going to be, at peak is going to be, would have the round tip. And for NH is going to be one spike. For NH2, this is for NH, and for NH2 is going to be double spike. That's for the that's for NH2, the NH group. And if it's a tertiary amine, there would be no peak around 3300 because there is no NH when it comes to the tertiary amines. The next group or next question, is there a CC triple bond or a CN triple bond? This peak would show, the signal for these is going to show around 2200. And same thing for CN triple bond. You would see a peak at 2200. If is a terminal alkyne and there is a CC triple bond and also a CH single bond, the SP, this hybridization for this is SP, when you have alkyne, and the hydrogen attached to SP carbon would show a peak at 3300. A different peak compared to the OH and NH because this is going to be sharp and short peak. For CN triple bond, it's going to be a strong peak, stronger than the CC triple bond, and it would be around 2200. And there is no NH here associated with the nitrile group. Next step would be to check if this compound is aromatic or is not aromatic. In order to determine if the compound is aromatic, we are looking for the presence of peak around 1600 for CC double bond that is coming from the aromatic ring, because the is a sp2, so we have the CC double bond. Looking for CH bond, and that CH bond that is coming from aromatic ring is coming. This is coming from sp2 hybrid, and if it's a sp2 hybrid carbon, the hydrogen attached to it would show a signal higher than 3000, so it's going to be between 3000 and 3100. Aromatic ring is going to show two signals, like kind of double signals, around 1500 and 1600. So you get like peak around 15 and 1600 and one peak at the around 1500. So if you have all three of them, that means your compound is aromatic compound. If your aromatic compound is substituted, means that there is a group attached to it. Let's say you have an NO2 group attached to this one. If it's mono substituted, another additional signal is going to show around 700. If it's ortho disubstituted, it would be around 750. If it's a meta disubstituted, you get two peaks, one around 700 and one around 850, and between 850 and 900. So these are the numbers that are not there because they are in the fingerprint area. We don't use it often, but just because I have included in the manual, lab manual, I wanted to mention how to use this as well. Next step, so we looked at the carbonyl, and then we looked at we had a question about, is this compound aromatic or not? So this actually is, we looked at if it's alkyne or nitrile group. So this numbering system. Now for this one would be 3 and this would be 4. is this compound alkene or not? If alkene, that means a CC double bond is present. CC double bond would show a signal around 1600, and also the hydrogen that is attached to CC double bond, this hydrogen bond would show a peak between 3000 and 3100. So if both of these are evident, then we know that we have a CC double bond. It's kind of with the aromatic and the alkene for the IR, unless it's substituted and these peaks in the fingerprint area, it's evident. They're very similar. For the aromatic, because of this conjugation, the CC double bond is going to show a peak at slightly lower number, like a 1575 to 1625. And for the CC double bond from alkene, it's showing a bond between 1630 and 1680, so slightly higher if it's not conjugated. If it is conjugated, it's going to have a higher number. Now, for the alkene, if based on the substitutions, and we can also see a signal in the fingerprint area for the CH that is coming from mono substituted around 900. If it's the H coming from di substituted around 900, and if it's di substituted cis, then it's going to be around 700. Di substituted trans is going to be at 950 to higher 900. So these are like additional information that you can use if the fingerprint area was studied. Now, the next question is, does this question contain any alkyl group? Most of the aromatic and most of the organic compounds, they contain alkyl group. The hydrogen attached to carbon of sp3 is going to show a signal less than 3000, between 2900 and the 3000, less than 3000. The compound, if it's ether, a CO double bond would show a peak around 1100. So we are looking at that for ether. CO, and also we saw it earlier, that shows a peak for the ester, but there is you have a number set for ester. You have for carbonyl, and you have one for carbonyl, and you have one for the CO single bond. If the compound contains a nitro group, you would also see a signal for NO double bond around 1500 and 1400, like 1350 and 1550. These are some hints or explanation of some of the signals that you could see on the IR to help you to interpret. One of the application that we used in prior experiments when we did the reduction of a ketone to secondary alcohol. So ketone shows a peak around 1700. Secondary alcohol has a peak around 3300. Broad peak is for OH. The IR spectrum can be used to check for completion of reaction or purity of the sample. If the sample is impure or it has leftover of a ketone, both 1700 and the 3300 would appear. If this reaction does not take place at all, you will not see any 3300. If 3300 is appears and 1700 disappears completely, then we know that there is a pure product of the alcohol, and there is no leftover of ketone. So that we also use for that application, beside for identification of the compound.